All right, so this is the lesson from yesterday. We'll see it again. Remember, we learned about the phoenix. Sorry, for those who were out yesterday, you missed the phoenix.
I'm happy.
The phoenix and that guy. There's nothing better than that phoenix fading into his picture. Okay. So we learned the derivatives e to the x, a to the x, the natural log function, which we were also kind of surprised to see was 1 over x, and the log function in general, base anything you like, and that's where we stopped. Okay, so now the last piece that we want to highlight here is something called logarithmic differentiation, and as our kind of the prototypical first example someone might go to talk about this is this function x to the x. So we'll take the derivative of that, and I think you won't. I think that'll be like the last derivative we'll ever take, right? We'll take lots of derivatives this year, but I don't think we'll have any other derivatives to share with you. After this, I think you'll be able to differentiate everything, anything that anyone throws at you. Okay. So the technique you're about to see is called logarithmic differentiation for a good reason. X to the x. Notice, let's just make sure we're clear. Notice that it can't fall to the power rule because it's not of the form x to a constant, is it? It also won't fall to our a to the x rule because it's not a constant raised to an x to the x power. So where does that leave us? So we're going to start by doing this. We're going to take the thing we're looking to take the derivative of and take the log of both sides. It can be the log base whatever, but let's take the natural log of both sides. And then we're going to use the log power rule on the right side. What does that give? Yeah, x ln x. Pre-calc. No calculus yet. No. So far, so good? All right, and then, now we're ready to do some calculus. We're going to do what kind of differentiation? Of course, our favorite, this unit. Yeah, it has to be implicit because we've got the y like all up in there. We're going to implicitly differentiate that, take derivatives, and on the left we'll have what? What's the derivative of ln y? What's the derivative of the natural log function?
1 over x.
1 over y times dy dx. On the right, we have to think about what the derivative of ln x is. It's 1 over x. But we also have a product rule to deal with, right? So make sure, just let me give you a second to stare at that and make sure you feel good about what I've written on the both sides. You like that? Well, I think maybe the rest, the powerful stuff happened at the beginning here. We took the log of both sides and that kind of set us up for success. Maybe you're already there, right? What are you going to do next? What are you going to simplify a little bit? Keep in mind your goal. We're trying to find y prime. So it's not bad to find y prime. Just multiply by y on both sides. I'm just cleaning up the right side. That's a 1 there. And then multiply by y. Let's just pause there for questions. Yeah?
No, I was going for a high five.
Yeah, by you.
So, like, why wouldn't you remove that from, like, x to the x?
Oh, yeah, you're ahead of me here. So, yeah, we're not done yet. I haven't, put this in a box yet. Yeah, you're right. We're going to keep going here. What's y? Again, anytime if we have to, and we're implicitly differentiating, and we have to leave it in terms of x and y, that's one thing. But here, if we can get it in terms of x, that would be better. And so, like Vinny says, hey, what isn't y just x to the x? And the answer is yes. So let's put that in a box as our final answer. X to the x times 1 plus ln x is apparently the derivative of x to the x. What do you think? You like that? Yeah.
Isn't that like a rule? Like,
The rule, no, this is not one you need to memorize. This technique is the thing you're memorizing, right? If you have some function, f of x, raised to another function, g of x, what are you going to do? And the answer is logarithmic differentiation. You're going to take the log of both sides, use the power rule, and then do this. So this is the kind of the thing I want you to, not the box. This is the thing I want you to think about here. How did we do this? Memorize the red. Don't memorize the box. Okay, yeah.
So like x to the 2x would not be like x to the x times 1 plus ln 2x times 2?
I don't know. You should check it. I have to think hard about that. Run through this and see if you get that. I don't know. Oh, you need it back? Sorry. What? Still good? Anyone else? So again, the situation, telltale sign that you need to use this technique is if you have a function of x raised to the power of another function of x. Here we have two very, very simple functions of x, just x and x.
James, I can't read it. Does that say y to the y?
What?
Y to the y?
Where am I looking?
Y to the y. Y to the y times y to the y. Is that what it says?
Y prime.
No, no.
Y derivative is not y.
Y prime.
Y prime?
I do.
All right, why don't you try this one as we head out today?
Oh, yes, right.
I'm going to write the solution up here quickly. Don't look up. Okay, you do it. It's not going to work? I see the bell's going to ring in a minute. I just want to make sure you have it before you do it. How are you doing? Can we do it? All right, see you guys tomorrow. Do your homework. I did that very, very quickly. Let's check. So, this is the derivative of this, right? This part 1 over sine x, and then times the derivative of
Use another cosine because that's
yeah, that derivative is going to be more complicated. I think that's right. I think I did it real quickly.